Hello, my name is Jim Robb, and I'm the president of the National Training and Simulation Association, NTSA. Welcome to our July webinar with the theme Virtual, Augmented, and Mixed Reality, Science, Fiction, or the Future. This is a big topic for us, and we're very excited to have this wonderful panel and these two great moderators. So I'm going to keep my remarks very short because we have a really full program and in an exciting format. In terms of administration here, the panelists have your questions that were provided in advance, and there will be an opportunity to ask questions in real time. So we probably won't get to all of them, but we'll give it our best chance. Due to limitations of the panel's time, we're going to try to keep this to an hour, but it could go a little longer if it's really working well. Finally, I would like to thank Inversus Training Solutions for sponsoring this webinar. We really appreciate your support. So let me now introduce our two moderators, Tyler Gates and Sebastian Lozay. Tyler is the CEO of Brightline Interactive and president of the DC chapter of the VR/AR Association. He is a visionary for the applications of VR/AR technology for training, enterprise, and branding solutions. He's a very strong supporter of NTSA and the ITSIC program, and we appreciate everything he does. Sebastian Lozay is simulations industry manager for Epic Games, huge. So during his career, Seb focused on learning about the latest simulation innovations, as well as sharing his experiences about how experts have solved their challenges. He's also a great supporter of our programs, and we appreciate everything that he does. So let me turn it over to Seb. Have a great hour, and I'll see you back at the end.
Thank you very much. Hello, everyone. First, I would like to thank Admiral Rob and René Despots and the entire NTSA team for, who allowed Tyler and myself to organize such an ambitious webinar today. I would like also to recognize the Next Big Thing committee, led by Dr. Wing Bennett and Bob Kleinempel. This webinar is the first milestone as many parts of many upcoming events, conferences, and research topics we will be delivering with that committee. The topic of XR is key and important for the simulation community, so much that we see it as a prime topic in our conversation with the NTSA, obviously, but also with the VR/AR Association, strongly represented in the defense and aerospace committees. It's important also to remind the work that's being done by the Kronos group with the OpenXR concept, as well as the CISO XR interoperability standard study group led by Paul Gustafsson, and which will be welcoming Dr. Von Helen from the 25th Air Force AFCO in their group meeting tomorrow, who will be presenting VR use for the US Air Force for ISR training. From government from the government and the institutional point of view, getting an OBS, a good grasp at what the industry and the private sector is putting together in the XR domain can be mysterious and a bit tricky to discover, right? Between the marketing claims of some vendors and the fast pace of communications coming from the industry, it becomes harder to identify what is upcoming innovation for the future, and what is actually tested, proven, and available today. We get a clear and simple to get a clear and simple message about XR, we have gathered an unprecedented group of pragmatic experts who will share their experience, along with great design tidbits of practical information. This session will focus on basically everything you need to know about XR for simulation, discussing content creation, hardware solutions, infrastructure, and solution integration. While traditionally, you might see the presenters aligned in this panel, pitching, facing each other, today, because this message is so important for the community, they're presenting side by side. So before we jump to the first panel, here's an important spoiler. XR is not the future. It is today. Thank you, and now I would like to turn to Tyler, who will introduce our first panelists and open our first topic of the day.
Great, thanks, Seb. All right, so we're going to start out with content creation, really the inception of when we think about generating immersive technology at scale, we think about content creation. And to talk about that, we have two great experts in the field. We have our good friend, John Cunningham. He is the head of government solutions at Unity. And then we also have Steve Smith, who is the XR lead at Epic Games. All right, gentlemen, if you will join us on video, we are going to hop into, we have two questions for this section, and it's going to go pretty quickly. Each of the panelists will have about 2 minutes, a minute and 30 seconds, about 2 minutes to answer each question. So first, just to kick it off, John, we'll start with you. In the broader ecosystem, what advancements have been made to allow for fast and efficient scaling of content creation?
So I think the fundamental answer to that question, it's really about democratization of tools, right? To enable creators to create XR solutions more efficiently, faster, and and that I think has accelerated this ecosystem significantly over the past few years. Also, as the hardware technologies become more ubiquitous and the cost of the technologies come down, that's also made it a lot more possible. But at the end of the day, it's about content creation, getting on the devices, having standards that make it that enable collaboration between the different technologies. And so the other thing I'm seeing that's really interesting, it's this adoption of the mobile VR, right? Mobile VR and mobile AR is really, all indicators are going, that's where the mass adoption is going to be. So we need to be able to create the ability for these creators to just get as much content out there as possible and have it interoperate with other technologies. So I think we're seeing a lot of very good progress in that area.
And Steve, what do you think?
Yeah, so I mean, I think traditionally the creation of content has been probably the most expensive aspect of generating visual experiences. And over the last several years, we've seen more and more options coming online to allow for faster and cheaper sourcing and generating of content. And one of the biggest advantages here is in the space of game engines such as Unreal Engine, where the focus has been on simplifying and unifying this process. In the past, there are a host of tools and systems that you need to pull together to create all of this content. And those required a broad set of specialized expertise. Unreal Engine continues to simplify and unify a lot of this effort. For example, in Unreal, you can create and edit content directly in the engine. You can do everything in one place. So one very recent innovation that we have actually is the MetaHuman creator system in Unreal. So going through normal traditional processes, creating a high quality human character was a massively time consuming and expensive endeavor. You're looking at probably $100,000 per character. With MetaHuman, you can stick someone with a pretty much any level of experience in a room somewhere, and they can churn out a wide range of super high quality assets quickly and easily. Content creators now also have a host of options for quickly sourcing high quality 3D content as well and pulling it into their experience. I'm specifically thinking about photogrammetry based assets found in content warehouses such as Quixel or Sketchfab, both of which, by the way, are now part of the Epic Games family. So where previously it would have taken many hours and huge teams of artists to generate these high quality 3D assets such as trees or buildings and so on, now there's these massive online warehouses with this content. And for users of Unreal, all of that content is free to use, which adds significant value and greatly reduces the cost of building that content.
I was muting, right? No, I think one thing that's interesting as well is the evolution of the teams in the simulation field, and that's one thing that we see a lot. There's a lot of evolution in the field, and a question for both of you, and that time I think we'll start with Steve. But what type of companies, individuals or skill set are needed to fully leverage these game engines that you're talking about? Steve, you want to start?
Sure. Yeah. I mean, it really depends on the scope of what's being created. So you're generally going to be looking at a broad range of skills to pull everything together. Building the same simulation applications with a higher end visual outcome will be a simple process for simulation developers only by virtue of using an engine like Unreal Engine's full set of capabilities. To really enjoy the full spectrum of benefits of Unreal, it would benefit creative teams to create opportunities for game developers and artists to join them to leverage their skills and experience. Having people with these specialized areas of expertise join creative teams will allow us to get to the next level and fully benefit the simulation community. For simpler experiences, systems such as Blueprints, the Blueprint visual programming system in Unreal, make setting things up simpler, and they don't really require strong engineering skills. But to create a truly innovative experience, you're still going to need strong programming skills. Feature-rich engines such as Unreal do remove the need for super hardcore low-level rendering and system engineers, since the engine itself handles all of that heavy lifting. But to really achieve the full potential of what these engines are capable of, you'll definitely need a team with some engineering chops. But the upside here is that all of that expertise and effort can be focused on making an experience that's truly differentiating and unique, rather than spending a massive amount of time and resources building that plumbing and foundational stuff. For animated human characters, you're still going to need people with expertise to set up animations, whether they're animating directly or using mocap resources. And for actually capturing performances of mocap, which is motion capture, you'll definitely need either dedicated resources in-house or to farm that out to a contractor that specializes in providing that service. Traditional content like 3D models, materials, and so forth are required to be created by hand. Or if it's required to be created by hand, that's going to require large teams and heavy time investment, a strong expertise in digital content creation tools, modeling, texturing, and so on. But then you've got content available via photogrammetry, Quixel, Sketchfab, and so on, or with systems such as MetaHuman. So developers can quickly pull together an enormous amount of extremely high quality content at a low cost and with less of that specialized expertise.
Thanks a lot. John, do you want to...
No, I think what Steve said is absolutely relevant. It's that the tools are getting easier and easier to use to really enable anyone to get into the platform. And I'm gonna go beyond the word engine, because I think this word engine is really, I'm gonna use the word dated, because now we're really getting into, these are 3D development platforms, right? And they're integrated with lots of other capabilities so that folks can quickly get into them, pull assets that are available through any different type of sources, different asset libraries, and be able to put those things to work. And so I think that we're really on the brink of a fundamental shift. And I'm going to use, I was in a meeting the other day and this came up. It's like the customer said, we want this to be the next PowerPoint. We want to be able to create simulations and scenarios as simply as it was to create them in PowerPoint. And that's something that Unity is completely dedicated to and working towards, which is really, about enabling this massive, 2 million person ecosystem of developers, and then getting the non-developers also into it.
Thanks a lot. Thanks both of you. I mean, it's super interesting to have Unity and Epic telling the same story. It's a very strong semantic for I think our audience here. We'll welcome our next panel. So if Steve and John can go cams off, we'll invite John, Chris, and Amir to join us for that part of the conversation where we will be talking about some of these devices that are making our life easier in that world of XR and making things actually possible. With John Burwell was representing Vario here. Amir was representing HTC Vive, and Chris was representing the team from Microsoft, and namely here specifically the HoloLens 2 in that very specific context. So we have a couple of questions for you, and we'll try to start in the order of the pictures first, and then we'll take the other order after. So the first question we have, and that's an important one that I think everybody from panelists to attendees to this session have heard many times. What are the biggest myths that you hear often that you want to debunk here now? And now about the scalability of the hardware. There are many examples, and we'll let you dive into them. What are the biggest myths that you heard, and how would you want to clarify on these specific points? We want to start with John.
Sure. So I think for me, one of the biggest myths that's out there is that VR headsets make people sick. Because that's a big factor with a lot of the customers we talk to, particularly those that are over 40. There's a good reason for this, and that if you look back, 6-8 years, if you put on a headset, or in me in particular, if I put on one of these headsets and I wore that for any significant amount of time and was immersed, because of a variety of different features, I would get violently ill. It is not the way now. And I think that's something that we can really thank Oculus for doing a lot of the physiological studies and development for that. But headsets these days are safe to put on. They don't make people sick any more than you get in an immersive dome type environment. There's always a few that may have been out drinking the night before that are going to come in the next day, and that they're going to have certain issues with that. The reason for this is because of all the new technology that's used in the development of modern HMDs. And so very low latency displays are being used. The software it does all sorts of work in terms of adding additional frames in there. If the update rates of the image generators that are driving them, the engines are driving them, aren't driving them at a high enough rates. And so there is that because of all that development there, it really does not make people sick. And so because the issue there with that is that some of the older people that may not be that excited about getting in there, a lot of those are the decision makers, and I think in certain cases they may be the ones that's going to hold it back on going to some of the major programs, because they haven't had the opportunity to see that the latest technology is really safe and great to use.
Yeah, I'll take it from here. Biggest myth I want to kind of dispel right now is the kind of community split between tethered and untethered devices, right? You have the whole concept where your tethered devices, you're going to be leveraging potentially a lot more compute, but you're going to be motion limited. Untethered devices are great. You can free roam around. A lot of augmented reality devices, untethered for that very reason, but they're weak. I understand that. I think the future of these technologies and future of these devices are where you have untethered devices that are leveraging other compute sources via streaming. So we have this thing, Azure Remote Rendering, which takes your HoloLens 2 and allows you to stream really, really high fidelity, complex models using multi-GPU cloud rendering directly to your device. So I hope in the future, the myth that untethered devices are weak, I hope in a year or two's time that no longer is a real argument, because they're going to have the same compute power.
Yeah, good. All good answers, and I appreciate the question. This, to me, honestly, is actually a pretty fun question to ask, because I feel like it gives us a really good high-level view of where we are at as an industry, right? Where we are at in the life cycle of VR and AR and XR. And I would have to say, for us at Vive, if you were to go back 3-4 years, you would probably hear a lot of those questions about motion sickness and just kind of the overall VR experience. But I feel like over the last few years, because we've spent a lot of time focusing in so much on the enterprise industry, that a lot of the myths that we see and the questions that we're getting is really about scalability. It's about, and very specific to certain industries too. We have, industries like healthcare and education, state and federal government coming to us and saying, hey, we love the Focus 3. We like the headset, but can we really get 25 of these, or 2,500 or 25,000 of these units, and how do we deploy these into a hospital environment behind a firewall? How do we, can we trust data security and data integrity if we bring this into a police department with Axon, or if we bring this into a hospital system with Penumbra? So these are really fun questions to ask, because usually the answers are quite positive and are definitely the things that they want to hear. So for us, it's really about scalability with patient care into private environments, government environments, classrooms and schools. And really my favorite question is, do we need a social media login? Do we need a Facebook login to use your headsets? Which I always love that question, because the answer is no. So in general, it's really fun to kind of look at where we're at as an industry. And Sebastian said this really well at the beginning of the meeting, where he said, XR is now. We're not talking about what can we do down the line. It's here. Companies, organizations, schools, educators have tested it out for the last 24 months, the last 36 months, and now they're ready to deploy. And that's where a lot of the people here involved in this call are helping make that happen.
Thank you. Tyler, we had a second question for that.
Yeah, no, thank you, Amir. And if we can actually start with you,
Sure.
back for this second question, really overall, what are you all doing as a community of creators in hardware that prevents the end customer, the enterprise customer, from being sort of locked in to your hardware? This is a challenge that even a decade ago, there's just a lot of I would say probably just a lot of frustration around kind of really wanting to invest into capabilities like this, but getting locked into these silos of hardware. So what are you all doing to sort of support the basically open frameworks, like Seb was talking about earlier, OpenXR and these types of things? What are you doing to support that?
Yeah, no, that's a great question. I think it is an important question, and even ties back a little bit to what I touched on about scalability. If we were to function in a closed ecosystem and said you only have to use Vive applications and Vive accessories, I think we'd be limiting our customers' abilities to really grow what they're trying to accomplish in VR. So you mentioned it. I mean, we absolutely support OpenXR and have been actively involved in that for quite some time. If you look at some of the, even just some of the examples that I used in healthcare, I mean, we work with healthcare providers like Penumbra, who actually build, custom sensors and custom kits that are designed to work with our headsets. Where maybe in other situations they wouldn't be able to do that, to actually custom develop a whole kit around our HMD. And even partnerships like with certain controllers. Whether it's Index's controllers, we're happy to bundle our headsets with those as well. So for us, scalability is important. We don't want to be a roadblock to a company adopting and expanding VR. We want to be a part of that. We want to be an accelerator of helping companies bring in VR to save money on their training organization, to bring in VR to connect their designers across the country to continue to develop, the next car or the next airplane that's being developed, or classrooms to take students on field trips in VR. We want to be a part of that. And I think we've done a really good job of being at the forefront, whether it was, in past lives in smartphones or today in VR. And we want to continue to support our peers in the whole VR community as we grow here globally.
Yeah, Amir, couldn't have said it better myself. I think one of the things that really helps adoption of these new technologies, I say new, emerging, fast-growing technologies, is the ability for everyone, students, professionals, to rapidly prototype on these hardware systems. And OpenXR support across all of our systems, the HoloLens 2, Windows mixed reality headsets. We are huge fans of OpenXR, but we also have this project called the Mixed Reality Toolkit, which we hope is doing exactly that, allowing people to rapidly prototype on a variety of hardware, on a variety of platforms. I think right now, the MRTK, or the Mixed Reality Toolkit, you can use on a variety of engines, or as John would say, 3D development platforms for OpenXR, Windows Mixed Reality, Oculus, OpenVR, Ultraleap hand tracking, iOS and Android platforms. And you can just mix and drag and drop all of these different platforms. You can find the code on GitHub right now. Again, push for open source. I'll be the one from Microsoft here talking about proprietary software. I think in our headsets, we do a very good job of making sure the entire community has access to all of this across all of the platforms. So I completely agree. And I think the ability to rapidly prototype and have everyone have access to this market is huge.
Yeah, and I don't mean to jump on the bandwagon, but I think I will on this, especially around OpenXR. If you're a hardware company, you need to understand that software solutions are what drives your business. And at Vario, we certainly understand that. And if every single developer out there needs to use a different API in order to access the functions of your piece of hardware, you're not going to be very successful with it in the long term. And so just from a natural business perspective, it makes sense to look at standards, and so we do that, and I think it's important too for the community to understand there's a couple of so-called standards out there. So you do have OpenVR, which is supposedly an open standard and really focused on VR in the gaming community, but it is actually something that's driven by Valve, and it's really focused more on the gaming industry. And so where we do support that at Vario, we also put much more effort going forward into OpenXR, because that's a true industry standard. It's driven by the Kronos group. It allows us to bring extensions into the mix. And so for us, we're doing a lot of work now in mixed reality, where you're mixing video and you're mixing computer generated content together to make a single scene, because we think that's a big requirement that we're seeing in the community out there. And so we're trying to build a bunch of extensions and functionality that's going to make that possible. And so by driving those standards into the OpenXR community, through both proprietary and open extensions to the standard, we're able to use that to really innovate, because what we want to do is produce these innovative solutions. And if we're stuck using standards that are based on other markets or other requirements, we're not going to get there. And so we do have our SDK that we use, but long term we want to try to support everything that's going to be coming out through OpenXR.
No, and I think that's +1 for the big conversation that we have at the NTSA for a very long time through the CISO group as well. That push towards standards is what making the community in simulation working efficiently. And what was true for communication protocols or for format of databases is also true now, I think, for the connection between the software world and the hardware world. And that's something that you pointed very well, the three of you. Tyler, I think we're almost good on time. We need to switch to our next panel. You want to introduce that one?
Perfect. Yes. Thank you, John, Chris, Amir. Thank you very much.
Thank you.
All right. We are moving on to section 3. Okay. Rapid pace here. We're moving on to section 3. Section 3 is about infrastructure. So really, when we think about immersive technologies, a lot of times when people think about immersive tech, spatialized technologies, virtual, augmented reality, mixed reality, we think about them as these almost like siloed technologies. But then when we start to see the capabilities, as we've seen over the last 2 to 3 years, continuously, the capability of cloud computing really starting to sort of take hold in many ways across the scalable markets for immersive technology. So in order to talk about infrastructure, we have 3 of the greats. We have Travis. He's a principal architect at Google. Pete, he is Azure IoT sales lead at Microsoft Federal. And then we have our good friend Ritz. He's the senior product manager at Amazon Web Services. All right, so with these 3 gentlemen, what we want to know from you all starting out, and we'll start Travis, Pete, and then Ritz. Overall, what is we understand that a lot of times in large scale simulation training specifically, we find ourselves in need of computing power on standalone head-mounted displays and things like that. And so what is the impact? What is the actual impact on cloud compute, cloud GPU, cloud CPU to the head-mounted display? How does this continue to drive forward the capabilities of the head-mounted display with cloud?
Sure, that's a great question. Thank you for having me, by the way. So I'm happy to kind of dive in here. So I think the first kind of misnomer is that everything has to happen on a localized device, right? And so we're kind of entering into this world. We've been in this world for quite a while, where sort of cloud is the new normal for CPU or GPU based processing for any number of use cases, right, including XR. And I think as cloud has emerged as this new normal, it's the sort of perfect globally available, very fast to interact with infrastructure layer that allows you to do any sort of offloading of processing from devices. So I think the impact is going to be huge over time, right? And Google is making a ton of investments in this area, obviously. I think some of the most important ones are networking. So, laying our own fiber, making sure latencies are as close to zero as possible, as physics will allow them to be. And also investments in hardware at the edge and hyper local capabilities, right? And we're all aware that, in a lot of these sort of AR, VR, mixed reality use cases, latency is sort of king, right? That's the thing that you're usually bound by. The compute capability, the GPU capability is all there and super scalable. Now we sort of need to think about how do we get compute as close as possible to the devices. And I think you're going to see a ton of innovation here, over the next few years, right? I imagine at big locations like stadiums and locations like hospitals, and a lot of the use cases of some of the other panels we're talking about. Imagine hyper local cloud capabilities with near zero latency, able to offload a bunch of compute from devices. I mean, I think that's a huge innovation that will impact the design of devices and the type of experiences that we can offer, right? Because now we can have these huge multi-GPU clusters doing this huge processing of things that might not be even capable on a local device. So lots of innovation to come.
Great, Pete. Pete, if you want to come off mute. Yeah, there you go. Perfect.
All right. Can you guys hear me okay? I was having some problems there.
Yeah, we got you loud and clear.
Right.
Just asking about the impact of cloud on the head-mounted display. What does this do to the capabilities of HMD when we start to empower it with cloud service?
Yeah, no, absolutely. Great question. I see the cloud is the simple answer being what many of the speakers have already talked about a little bit, which is the ability to render those AR, VR, MR visual experiences in the cloud, right? Streamed directly to the device, or even some other type of mobile device. So what that does is it prevents the head-mounted display from having to be as powerful as maybe traditionally. But for graphic intense workloads, because as we know, visualization data sets and they're just getting bigger and bigger. So rather than trying to offset by continuous refresh and purchasing additional beefy hardware at the endpoint, we can do all of this stuff and have all of that power of the cloud, planet scale compute with elasticity to be able to adjust however you see fit, right at your fingertips. Everything from just different GPU SKUs to memory, from storage, and you can manage essentially the demand of that workload at scale. One of the things that is really important about kind of AR, VR visual experiences is that the same plumbing that's used to power many of these workloads today are the things that are powering our games. So when you look at the gaming industry, you see a shift towards kind of cloud computing gaming at Microsoft. One of the things that we say is that, playing what you want, where you want is the next kind of stage in gaming. I see that as essentially the next stage also with, modeling, simulation, and the community that we're servicing here, basically leveraging that technology as well.
Yeah, thanks, Travis and Pete. So from the AWS side of things, the good news about the cloud is that you can have really all the compute power that you want, right? If we were thinking about the head-mounted displays as being potentially compute limited, well, the cloud is compute unlimited, right? That is the elasticity and the value prop of the cloud, with so many choices of, I think, Pete, you were talking about the different SKUs between GPUs and compute and memory, and you can have all of that, and you can customize it however you'd like in the cloud. So there's plenty of different choices for mixing and matching memory and graphics and compute. The other thing is the cloud allows you to run at a scale that you really couldn't otherwise, and it's not really just scaling scaling out horizontally across a lot of various compute platforms, but also building bigger, like building bigger simulations, right? Customers have been asking us, especially here at AWS, I've been hearing a ton of this about building bigger, higher fidelity, more lifelike simulations, whether you're using that for synthetic training, or you're wanting to create this really lifelike digital twin of a very complex environment. And cloud allows you to reach that scale that you wouldn't otherwise on the local device. I think perhaps we need to start thinking about the HMDs as the head-mounted displays as the immersive viewport into the virtual world instead of the virtual world itself, right? So if you wanted to create a large-scale simulation with lots of interesting things happening, that's something that's going to be limited by your local hardware, but not in the cloud. And at AWS, we're always looking for ways to make it easier for customers to run these large-scale workloads, especially through our high-performance compute, the HPC offerings. And so now if you want to take advantage of this additional compute power, the next question that we get from customers is, well, how do you get it back down to the client, right? How do you get it back down to the head-mounted display? And that's where the streaming comes in. And I think Travis and Pete kind of hit on this. And it's not just streaming. It's streaming on a reliable, fast, and low latency network, because that's one of the reasons of having the hardware on the device is latency, right? So with AWS, you don't only have the AWS Global Accelerator, which puts your data on an efficient AWS network, but we have the AWS Outposts, which essentially you can move compute right to the edge. You got local zones and wavelength. Travis, I think you hit on some of these concepts as well. Wavelength being the sort of the 5G offering here. So there's a lot of these emerging technologies that are converging to actually help reduce latency at the edge and get these workloads and this streaming capability back onto the device. And then Pete, you were right on when you said we see a lot of the game sort of technology shifting, because actually where I work in game tech, but it's also really becoming sim tech, right? So we see a lot of crossover in the tech that is helping game developers deliver low latency gameplay to players, taking hold in public sector. And we'd love to hear and learn from customers and their needs in this space. So yeah, please reach out, because this is going to be a very, very interesting space here over the next few years. Oh, now and over the next few years.
Yeah, there's another bit that's a tricky one, but interesting. Some might perceive that the costs of cloud are high, and how do you explain how these costs translates into value for your customers, right? Can you discuss some of the other benefits that it brings to the customers? Because sometimes there's a misconception about the total cost of ownership of an IT system. Do you want to start, Rix?
Sure. Yeah, I've got on mute now. So if you look at how and sort of why people end up moving to the cloud, the conversation starter almost always ends up being cost. And cloud allows customers to trade capital expense for variable expense and pay for IT as they consume it. And the variable expense is going to end up being much lower for customers than what they can typically do themselves because of the economies of scale that the cloud providers can achieve, right? And a lot of times when people look at our cloud pricing, and I think this might be true for the others as well, they look at the on-demand prices and they say, wow, that's really expensive. But in reality, there's a lot of pricing flexibility. There's free tiers that we offer that allow you to experiment with no risk. If you'd like to pay for capacity up front, if you know you're going to use a lot of compute power, you don't want to pay for 1 or 3 years up front, you can do that and make those commitments. You can also make commitments to just based on usage and the number of hours you're going to do. And we also have spot workloads, which are basically, if your workload is stateless, you can save up to 90% on your cloud computing costs. There's plenty of tools we developed, Cost Explorer, auto scaling, which allows you to make sure that you can match your capacity to your resource usage. And even if you're doing storage in the cloud, we have intelligent tiering in our S3 service that allows you to move assets between frequent and infrequent access and save costs. And there's the other piece of, we're constantly reducing prices, and I think this is true across the board, where we're always looking to pass on cost savings to customers. We've cut prices 107 times since AWS's inception back in 2006. That's 9 times a year, effectively, right? So we're constantly looking for ways to pass on these cost savings to customers, and cloud allows, really 4 things. 1, agility. customers can spin up the resources quickly when they need them, whenever they want, for how long they want. Elasticity. You don't have to guess about your capacity, right? You don't need to procure a bunch of hardware and say, I think I'm going to need 1,000 servers, and then you only end up using 100. You know, that math you don't have to worry about. You don't have to worry about, you know, the cost of deprecating the hardware, or where to store it, or how to power it, or how to set up the network. That's all taken care of for you. Innovation. Innovation is much quicker in the cloud because we have at AWS over all the different services, over 180 services that you can, across storage, compute, database, that you can use right when you open an AWS account, right? And deploying globally in minutes. You could be everywhere. We talked about some of the edge locations, the 5G locations, 80 availability zones, 25 geographic regions, and so you get all those benefits of the cloud at a cost that is going to be less than what essentially you could do on-prem.
Thanks a lot. Pete, do you want to comment?
Yeah, for sure. Hope you guys can hear me okay. So, Mario, great answer. I think with Microsoft, we've got many of the same types of ways to address cost. But it's an interesting question about cost, because cost is not always necessarily about the consumption cost itself. I think it's the crux of that real question, I think, has to do with translating value to the customer. What you'll find is that many of the competing cloud offers will have different types of consumption-based pay-as-you-go versus fixed costs, and different SKUs and things to that degree. We have all of that. But let me offer up kind of a couple of different benefits that I think add additional value, which you should factor into overall cost savings. So we talked about just the benefit of having kind of planet scale compute available to you on demand, right? Boom, that's a no-brainer. One of the things also is having that workload, your AR, VR workload, pretty much available anywhere you are, always able to connect, whether you just have an internet connection, and you can get the same experience on any device wherever you need. That's invaluable for where kind of the industry is going. A big part about cost is not only to the consumer, but the people that are developing it as well. So development is really accelerated by going to the cloud. You've got a huge amount of ease in terms of use of added features, updates, enhancements, and things that you can do on the fly, and distribution of those workloads become far more fluid. The second thing I think, especially in sectors like the public sector and federal defense, is security. Your source data remains secure while you're rendering that image and it's transferring. I don't think a lot of folks kind of think about that with a heads-up display. Sometimes you may have to put the entire, you have to manage your workload differently than if it were kind of sitting in the cloud. I think then there's some other just huge cloud benefits, AI, analytics, live ops. I'll talk about one last one that I think is really important. So Microsoft, we've got something called PlayFab, which is live ops. And this is going to allow really developers to focus on building out really great AR, VR, MR kind of experiences instead of having to worry about the back end plumbing, hardware, and things to that degree. I'll talk to you about a couple of different things that you can do, right? Matchmaking, parties, chats, leaderboards, statistics, different ways to engage with the users in that experience, to retain them. You can track that. You can do analytics. You can monetize different aspects of your experience. Content management in terms of managing remote updates to different workloads. You can do experiments, right, with different payment types of processing, virtual currency, guarding against fraud, connecting with pretty much players on any type of platform. There's other workloads too. You're not limited to having to have one workload or a small subset of workloads per device. You can actually have a Xbox-like Game Pass Ultimate experience where you can manage thousands of different simulations on demand. The other thing about PlayFab too is it's got compliance around all of the GDPR, COPA, and other government kind of regulations. So I think that that's probably important as well. And then last but not least, when you're running something in, certainly in the Microsoft cloud, something that's really important to us is sustainability. So we offer different tools when you're doing all of this high intense compute to be able to track how you're moving towards getting to kind of a carbon zero. So.
I think that makes a lot of sense. Travis, do you wanna comment on that, on this point? I mean, a lot has been said already, and we're exceeding a little bit of time, but there's so much value in these conversations that we can't stop you guys. Go ahead, Travis.
Sure. So I think I totally agree. By the way, Ritz and Pete have done a great job kind of outlining, the fundamentals of, how you can achieve better cost to value kind of ratio, right, with cloud. I think where I would take it in a little bit of a different direction for Google, right? The way we see the future is helping customers actually achieve this value and optimize for cost. What we think that kind of looks like is building out distinct services that actually serve these kinds of use cases. So services like Immersive Edge or the other sort of streaming platforms that you've seen Google invest in over the years. I think that's going to be a really important part, right? Just like there are capabilities that are already built into the headset or base capabilities at the cloud layer. I think there's room for a distinct set of services that customers can just kind of turn on, right? Once they're done with their creative work, and the cloud has enabled that as well, and they're on a virtual machine, they do something great. They want to push a button that says, I want to publish this, and I want my customers to be able to stream this to any device, anywhere. They want to throw it on a website or head-mounted device. And we want to make that whole end-to-end process as easy as possible. So as of right now, right, we've got services in production that customers are using and seeing success with at global scale. And so I think it's time for folks to just jump in. I would say reach out, hear more from all of us, right, about the projects that we're working on and the enabling technologies and software and services. So the time is now. So close with that.
Thanks a lot. I mean, that was a lot of great insights, and we'll move to the next panel at this point. Thank you very much, Ritz, Pete, and Travis. Hey, Nick. Hey, Scott.
Hey, guys.
Hey, Seb.
Hello, Jason. So we have our panelists for that part where we're going to be talking about integration. Actually, we've seen all the ingredients of the recipe here, but we need cooks, and we need cooks to tell us their stories about how they're assembling all that and what it means to change the paradigm in the way the next generation of simulation applications could be developed. Because we're a little bit pressed by time, I'll go very, very fast. But we got Nick Bikanich, who's the Chief Science and Strategy Officer at Red6, Scott Schneider, who's the CEO and co-founder of HTX Labs, and Jason Powers, who's the Chief Creative Technologist at Brightline Interactive. I got a first question for the three of you, and let's start in the order of our pictures here. Let's start with Nick. Today with the evolution and everything we talked about, there's still some people who have limited understanding about XR and the benefits it can provide. Are you still facing some level of reluctance from the end users to consider XR solutions? And if it still exists, what are the blockers you bump into when you have your meetings with people you're exposing to your technologies?
So I'll keep it really quick. Aside from the obvious blocker, I'll answer in reverse. Aside from the obvious blocker, namely, there are still some people who have yet to try various aspects of XR solutions. And moreover, there is still, sadly, at least amongst the DoD base that we end up dealing with, in many instances, an unexpected lack of understanding of the differences between VR and AR. The amount of times, I've lost count of the amount of times that I start talking about augmented reality and what we are doing, only to be asked questions relating to ground simulators. So there's a little bit of that, but in general, overall, there is way less reluctance than ever before. People tend to be embracing the platform in a significant way, in a traditional sense. What we are doing is quite unique and different because, as you well know, Sebastian, but some of you who are listening may not, we are doing augmented reality outdoors. We're doing video games in the sky. And there is reluctance to do that simply because people don't think it's possible. They don't think it's possible to actually do a full metaverse-like experience where you're synthesizing and connecting live assets and synthetic assets. So I would say overall healthy skepticism, but we are doing our best we can to break new ground and break these stereotypes as much as possible. That's it.
Yeah,
it's quick.
Thanks a lot.
Yeah, I'll go ahead and jump in. Yeah, Nick, I totally agree. There certainly is a level of reluctance. And for us, that's been primarily on the private sector side. A lot of pilot project proofs of concept, kind of dipping their toe in the water before they really fully go into an XR program. And I think some of the challenges are around how do you define that high value use case? Show a quick win, show real value, generate some momentum, get buy-in at the highest level possible so that you can really sustain the program. Where we've seen a lot of adoption is on the military side, on the DoD side. And frankly, like the U.S. Air Force is placing lots of bets around immersive tech, and whether that's an SBIR or whether it's any kind of contract where they're putting a lot of bets out there and seeing what sticks. And with the DoD, we don't have to convince them of the value of simulation technology. They've been using sim tech for 40, 50 years, just in full motion simulators. So what we need to do is put that simulation in a headset, make it more accessible, portable, and usable. Others touched on the blockers. Not a lot of content. Content's very expensive to develop. And so those who can kind of build the tools that allow for low code, no code content creation, where I can put a F-16 pilot in a virtual F-16 and let them create the content. That's where we're going to drive the cost of content down and the value of the tech and the training up.
Yeah, and just to reiterate Nick's statement, we definitely run into folks who either their only experience of VR or AR is a mobile experience, so they haven't experienced the breadth of headsets and the level of quality that we're able to get. And we run into blockers around kind of the on-the-ground folks in training they just don't see that VR is capable of, they think it's going to replace hands-on in-person training. And where we need to educate them is that it's not necessarily completely replacing it, but it's supplementing it. And it provides that kind of episodic memory and the physical aspect of training that really sticks for folks and allows them to better experience the actual in-person training.
You're muted, Tyler.
Double clicked it. All right. Thank you all for that. And just the last question here. What are you doing right now on your programs? What you can talk about. What are you doing on the programs that you're working on to ensure similar question to what we're talking about in the hardware section, really to ensure interoperability, but less about the hardware and more about interoperability of an entire system that's being delivered to a customer. Really, what we're talking about here is how are we ensuring the capability of future-proofing these types of offerings? And JP, why don't we start with you and go back reverse?
Yeah, this is a great question. The interoperability, a lot of it comes with working with industry standards. A lot of the standards coming out from Kronos Group, OpenXR, GLTF are they're getting increasingly mature and getting increasing adoption across the industry, and that's been really beneficial for us when creating solutions, because the adoption of that is only going to grow because it is an industry standard and it's an open standard. The other piece is with the proliferation of high-speed, low-latency connections like 5G and edge compute. What we're seeing is that allows for somewhat headset-agnostic, high-quality experiences as well as faster iteration and collaboration for both us in development and for creatives to be able to, through things like CloudXR and Omniverse, collaborate in the cloud and work faster regardless of their location.
Yeah, so I'll jump in and interoperability, future proofing. It's hugely important and something we've been thinking about at HTX Lab since the beginning. We're kind of historically enterprise software integration folks, and so we've always believed that a platform is part of the solution. But more importantly is that integration first approach. JP mentioned this cannot be a replacement strategy. It's got to be an augmentation strategy of an existing learning ecosystem. So to the extent that you can build a platform that has an integration first approach, leverages the cloud, leverages commercial gaming technology from Epic and Unity and others, you've got to be able to fit into and connect up to an LMS or cognitive engines or whatever the case is. And future-proofing, that's on us. It's not on customers. We've got to figure out how to protect today's investment and allow them to invest in the future as well, and not think about, okay, should I wait for the next headset? Should I wait for the next capability? We've got to help them on that journey, because this is something that's not natural, I think, for a lot of industries, laggard adoption. So we've got to help them on that journey.
On our side, as far as interoperability specifically, the fascinating thing is that since we're in the, I hate to use the word metaverse, especially in the last 48 hours, because it's been hammered so hard on social media, but since we are building the fusion of live environments with synthetic environments outdoors in daylight with objects moving 300 miles an hour, we have a particular problem with interoperability, because we've got to interface all of this stuff with real existing hardware platforms. But it's vital for us, because it's essentially an existential threat if we don't do it. And I mean, it's an existential threat to us. If you're a big, shall we say, a government prime, to pick the DoD context that we operate in, if you are a Lockheed or a Northrop, the way you try to win, the old school way, is that you hold everything really tightly close to your chest. You make everything proprietary, and basically if the government wants to buy one piece from you, they got to buy the whole piece, and good luck trying to make it interface with anything else. Well, the thing is, the government no longer wants to operate that way, because they realize they gave too much power to these primes, but the primes don't know how to think in an interoperable way. So our biggest advantage, and I say this as from personal experience, but this is a recipe for any startup that wants to work in this space, is to embrace interoperability entirely, because ironically, it's the customer that wants that, not just the industry. So that's what I mean by it's an existential threat for us. So it's absolutely, when the short answer to what are we doing to ensure interoperability is everything, because without that, we long-term get into serious trouble.
Thank you a lot, and that was our last panel for now. We plan to have a lot of time after to have Q&A session, and fortunately, we probably have time to take the two top questions that we have in the Q&A session here.
Yeah, Seb, we can actually keep going. For everyone for everyone who has to leave right at the top of the hour. We certainly appreciate you joining us on the webinar, and we also appreciate all of the panelists for joining us as well and sharing your expertise. And for the panelists that are able to stay afterwards and answer some questions, we would certainly love that. I'll certainly be staying on. But go ahead, Seb.
No, yeah, I was looking at the questions, and I mean, first of all, I mean, we had a great session today, and these panels was incredible. So thank you very much to all the panelists who joined, in some cases on short notice almost. Thank you very much for presenting today. There was a lot of knowledge shared, and in a very core essence of the messages that you shared with the audience. There's one question that is very interesting, that some of us already alluded to, but the question is the following: Can the speakers address VR, AR, XR applications that needs to also integrate with live reality. What parameters are most important to make this work? And there are several of our speakers who can join us now and give us their point of view. I'll let you jump in to answer to these points.
Yeah,
John,
I'd like to take that if we're opening it up. So I think one thing that we didn't talk about, right, is the U.S. Army IVAS program. I mean, if the topic of this is about augmented mixed reality, science fiction of the future. I think when we look back and we're going to see that the moment that the Army committed to the program and awarded the contract to Microsoft was really a milestone in the adoption of XR. It's like, no kidding. This is now a $21 billion program, right? That is using emerging technology. It's using XR, and it's going to incorporate real. It's true mixed reality. So there's a lot of challenges there that we're having to deal with on that program in terms of the ability to get real-time data, terrain data, be able to differentiate between what's real and what's virtual, taking it from the battleground into the training environment. So I think, in the spirit of the theme of this, I think this is a very important program.
That's a very good point, John, that you bring. And while IVAS is in the process of being developed, it's good to also have the point of view from Nick here, where basically the program they start developed is actually live now and running. So Nick, do you want to give us a word about what you're developing and how you're connecting reality and virtual elements?
Absolutely, and Sebastian, thank you. You were helpful for those who are listening who want. If you scroll through the chat, Sebastian dropped in links in there. Timing lined up very nicely. Unreal Engine did a spotlight on how we're using Unreal to do specifically some of the connection of the live and the synthetic environment. The short answer to what's the biggest problem. Honestly, the answer is latency. And I mean, I know that's a dead horse for everyone because in the motion to photon stack, it's a big problem. But it's inevitably the problem scales up even further when you start moving entities around at multiple hundreds of miles an hour. Or when you're making a multiplayer outdoor game, then you need your super low latency data mesh. And because ultimately, yes, you can motion estimate, you can like magic away a certain aspect of the latency, but the less you have to magic away, the better. There are significant tracking issues involved in doing this correctly, but ultimately, this is an inevitable part of the future. And by the way, this is not just about training. I know that IVAS focuses on training initially, as do we, for obvious reasons. Chief amongst them being that the moment you enter into non-training environments, you have to have classified communication on top of the irregular problems with latency that you have. But it is inevitable, in not just my opinion, but many others, that the problem we're trying to solve here is real-time visualizations of complex data sets with moving humans. And yes, in a training context, that means we are drawing synthetic assets. But in a non-training context, it means you can draw any form of sensor fused data or any form of overlays, markers, whatever might be interesting to illustrate. There are massive integration problems. There are massive latency problems, and chief amongst them, the ones I alluded to. But yeah, I mean, I can go further, but I don't want to. I know we're running out of time, so I don't want to over-dominate the discussion. Bottom line is, check out the link if you want to know more. And thank you again for having me here.
Thanks, Nick.
Thank you very much, Nick.
All right, let's hop into another question here. There are definitely a few in here that are meaty for the rest of the crowd. And if any of the panelists see a question, you just want to hop in and come on video and start answering, you're also welcome to do that. Let's see. This one here at the bottom, the last one, we'll go for that one. How do XR applications merge into creating what is referenced as the metaverse, and what is required of AI for that process? This is a very broad question overall. lots of different ways to answer this. But if any of the panelists want to hop in and explain this, and if there aren't any, then Seb and I will certainly take it. I mean, overall, really, what is being referenced when we say when metaverse, that the term is thrown around, is really, again, like, and we kind of talked about this when we talk about the interoperability capabilities, and as well as the abilities of cloud compute. What cloud compute sort of does to these technologies overall. When we think about sort of doing a VR experience, let's say, you don't necessarily think about doing that experience with lots of other people all at the same time, or being in a shared environment, or let's just say being able to interact with multiple different devices, different operating systems across the board. So not, it's where you have the ability of different head-mounted displays to be able to enter into a virtualized environment while there are other head-mounted displays also in that space. And so you're talking about, in a kind of the connective tissue across all of these immersive and spatial platforms is this idea of a virtual space that exists at the same time as the real world. Another sort of easy way to kind of understand and see this sort of taking shape is when we start to sort of move with augmented reality beyond sort of, I would say, these AR that sort of launched from the phone, where you have augmented reality assets that can actually be dropped into physical locations and can be actually anchored to those physical locations. And so you really actually have this virtual layer that exists in the real world. And you just can't see that virtual layer with the human eye. You need a device to be able to access that virtual layer. But that virtual layer can be completely contextualized to the circumstance that you're in, regardless of when you are or where you are. You can be completely contextualized inside that physical space, and you can augment that physical space with various different types of assets. And I know, Nick, this is essentially what you're doing, so feel free to pipe in here.
Well, I wanted to add in a little bit about the question was asking a little bit about AI and how AI plays into there. I wanted to add the concept of range. And because, I mean, I'll use a specific example of air combat, but range is similar in many, there's a similar analog in many instances, up to and including normal human-human interaction in a civilian context. At the end of the day, the interaction, if you wanted an AR, shall we say, digital twin of some sort, my interaction with another human is very different if they're driving in a car and they are 20 miles away from me, versus if they're in front of me and I can wave my hand and or touch their hand and or read the expression on their face. It's very similar in combat, and the AI is very different. So the AI required to do, for example, so-called beyond visual range tactics, broadly speaking, where the vehicles, aircraft, for the sake of argument, sit, and where they approximately wish to go, is very different to the kind of AI when you enter into a dogfight, which is the equivalent of the handshake, very close communication. So it's not just necessarily about AI as a standalone concept. It never really is, even though the term is used amorphously. It's about the interfacing between and the handover between the various different AR models. And that's just beginning to be done. We are certainly, we're not part of defining the AI pieces yet, but we are interfacing with a lot of them. It's also worth, it's a nice aside, and I'll just throw it out there because I think it's interesting for a lot of people. We spend a lot of time talking about the data that we are bringing to the eyes because we talk about the visuals. That's a lot of what discussions about AR, VR, XR are about, is what can we bring to the head of the person, pilot, whoever, warfighter. But let's not forget that pretty much the same problem set involves its solution to the same problem set gives us data from the head. And that data is vital, not just in terms of what you're looking at and when you're looking at it, but also all the other biometrics that can be associated with this, because it's when you fuse all of this stuff together that you end up with an ecosystem that you can train on, use, and then debrief correctly. And that's it. Sorry, I went sideways, but I got excited.
No, that's fantastic. Thank you, Nick. What else here? Any other panelists, if you see a question that you specifically want to answer here in video, hop in here. Let's see. This is a relatively straightforward one. Do HMD specs, do head-mounted display specs specify latency, or how much has been shaved off over the last several years? There we go, John.
So I can certainly talk to that a little bit. I think each HMD in itself, there are certain factors that drive the latency up or down based on the materials that are used in developing it. And I think if you ask the vendors individually, you should be able to get some indication of that. My recommendation on that is to actually run real tests, just because there's a lot of dependencies on defining what that latency is based on the different applications that you're running and some of the specific use cases. So it's always very good to test, and especially since a lot of the vendor specifications are very much optimized to look good in a spec sheet versus what you really need. I know at Vario we do a lot of work, especially trying to minimize the latencies of the video feeds. So, we have the video see-through cameras that have two 12 megapixel cameras, and that's a whole lot of data. And so we do a lot of work to try to minimize the latency of, capturing that data at the camera sensor and then getting that down all the way into the GPU. And so there's a bunch of different ways to measure that, and there's a bunch of tricks that you do with it. So for example, we use foveated rendering, which will minimize the amount of data that has to be sent through. In some cases, you might need all of the data versus just the highest resolution of data. So we try to keep that transmission under 20 milliseconds, because that helps when you're trying to combine the camera data with the CGI data in a mixed reality application. But it's to try to come up with sort of a set of specs for that, you're going to run into all kinds of very specific cases that are use case dependent. And so again, recommendation there is to test it out yourself.
Thank you, John. Appreciate that. This is one here from Tim Fitzpatrick in chat. Also, what do you think is the single biggest inhibitor for customers to bring XR into their business models? I want to throw in here really quick, Amir, before you go. I would say that there was a time, certainly for us, we started a little over 20 years ago, working on an Army contract in the early days. And there was certainly a time when the capabilities of the technology weren't at the pace of our creative. But now, it just doesn't exist. We're now no longer limited by the capabilities of the technology. Rather, we're actually limited by people's ability to be creative and be sort of proactive with them. I would say that the single greatest inhibitor is people's awareness of the actual impact of immersive technology, what it's actually doing, how we're actually able to understand content and context at the exact same time, the ways that we're able to virtualize embodiment, the idea of embodiment, your awareness of proprioception, your awareness of your sense of self inside a virtual space. Lots of sort of awareness and understanding around these technologies are still sort of that they're just sort of like the next step, an upgrade from the previous capabilities, the previous technologies, and really we're just sort of at the inception of these technologies sort of essentially changing the way that we understand the world around us, changing the way that we understand how to even communicate with one another in the first place, teaching us brand new ways to communicate with one another. And it really is until decision makers become aware. You heard it multiple times from the panelists. If you haven't tried XR, it can be really difficult to sort of strategize and be creative with it. And so what we find oftentimes is that the single greatest inhibitor is that the end customer has, can tend to sort of see these technologies inside a very tiny box without being able to sort of understand how they connect. And we can see, really, and it was sort of exemplified really on this panel, but I would say that, what gets us into Industry 4.0 is we have to significantly enhance our ability to become aware of things. And so we can't become aware of things in the same way that we have become aware of things in the past. And what we're seeing now is the convergence. You have this sort of confluence happening between 5G in many ways for transport speed, but then you have cloud compute for all of the things that we talked about for sort of processing in cloud. And then you have spatial technology. So where you have this sort of convergence of these three exponential technologies, we start to see communications overall change. And I would say that it can be very difficult when the understanding of the technology is great. This is a cool thing that I just put on my face, and it sounds like a cool update from what we were doing before. And it is massively, massively more impactful than that. Sorry, go ahead, Amir.
No, I was going to say it would be hard to top your answer there, Tyler. You kind of covered quite a bit of I think the right response for that. I think you mentioned this, right? It's really about right now for companies how to just get their hands around the end-to-end solution, right? A great piece of hardware doesn't have the same impact for a business if they don't have the right content and the right content bundled with that, and even the hardware and the content together. To make sure that that's being deployed and used broadly, not just for the one or two project owners within a company, but how do you get that actually adopted beyond just one small team or one group of users within an organization that sees the value of VR? So, I think for us, and I think for a lot of people on this panel, it's just about, bringing together these solutions of the hardware, the content, the management of the users and the management of the content out in the field, and making this just more attainable, more within reach, and much more easily scalable, for organizations. I think if anything, the last year and a half has shown us is that companies have really accelerated past the, we think VR might be, good for us. We think XR might be good for us. We're still testing. We're still kind of dabbling in this. The last year and everybody kind of dispersing into working from home and school from home and all these things has really strapped a rocket engine to the whole industry and forced companies to say, yes, we can do everything in Teams or Zoom. That's great. But we are still very limited in what we can experience in a two-dimensional setting. What can we do to be more immersive? And what can we do to bring more immersion and more, spatial and environmental awareness to the content or the meetings or the projects or things that we're hosting? So, I would say the demand is at an all-time high, and I think we're continuing to see how we can piece together all these different ends of the solution into something, customers and users can really grasp.
It's great.
If I can ask something, because I think Tim answered a really good question. Tim, that was a great question. I think two of the biggest challenges that we got right now for business models, right, is one, what is the ROI? Because customers that I work with are still wanting to they need to calculate. When you go and ask for a multi-million-dollar investment in an organization, you need to be able to quantify what is the return going to be. And look, there's a lot of data coming out there. I think it's there, but each individual organization has to be able to explain that internally. And we in the industry need to help companies with that, right? Second thing is we've got all these complex business models between complex royalty structures and usage consumption-based models. How can I, as a project manager in an organization, go to my management and say, I need a budget of X dollars to do this, when you've got all of this complexity? Because at the end of the day, it's bringing different technologies together to make it work in a solution. And I think as an industry, we just need to get better at that and make it simpler for the end user.
I think you're right, and I think a simple simplification that we did put in place is to make Unreal free for the government entirely, right? I mean, the royalty structure works for the gaming world. In the simulation world, it doesn't apply at all, right? So simplifying and adapting the business model to the industry is something that the commercial world have to adapt to. And for us, it was a learning process, right? I mean, we had to realize what was the best approach. And I think you're totally right. I mean, the evolution of the mindset and the evolution of the business model is as important as the evolution of the technology itself. We're running really short on time, so
Yeah.
Tyler, can you conclude for us today?
Thanks, Seb. Perfect. Yes. Once again, we wanted to say a big shout out. Thank you so much to Renee and to Admiral Rob for inviting us to host this July's webinar, and thank you very much to my co-moderator, Seb. Really appreciate all of the support as well. It's been a lot of fun doing this, and please continue to reach out with questions. We'd love to. We have a list of questions here that we'll try to get to for, certainly in response. And just again, thank you for all of the registrants. We certainly appreciate your thoughts, the chat, very healthy chat going on. We really appreciate just the ability to have this discussion and to hear incredible questions and honestly to hear from some incredible panelists. Thank you very much.
Okay, so I really appreciate everybody's efforts on this. This is a fantastic panel. Tyler and Seb, you really promised greatness and you pulled it off. So well done. You covered a lot of topics that NTSA is deeply interested in, and I'm glad that we have all this recorded because I'm going to go back and try to unpack it. We talked about devices, standards, cloud-enabled, integration, open architecture, latency, ROI, business models. These are all key to making the market for these capabilities, certainly within the military. And over the last 10 years that I've been working on this, the folks, they're enablers, and then there's disablers, and cybersecurity, things like that are, when you have to encrypt everything, these are things that are hard to do, and I appreciate the fact that we're having these discussions. I wanted to follow up on one thing Tyler talked about early on, which was the next big thing committee for NTSA. This is something I commissioned earlier in the year as part of my continuous drive to find and identify next generation enablers for training and simulation solutions. So Tyler's part of it, but we've got a wonderful mix of scientists and engineers that are coming together to help advise me on what NTSA should focus on, and I appreciate all of those efforts. And say join us if you want. In terms of our programs, I just want to update you on the status of ITSIC. We're planning on an in-person ITSIC in Orlando, and I think it's looking well. There are some variant kind of things, but we got a lot to go, and I think we're going to enjoy an in-person, certainly big show floor, which is almost sold out. We built a conference program yesterday in Louisville, and it's extremely rich in AR, VR, and XR, both on the show floor, but there's an entire track of technical papers on the subject. So this is something that we're focused on. We think this is a journey. This isn't a solution. So we're encouraged certainly by the investments that the government is making in these capabilities, and appreciate everybody. Don't get discouraged with the government. Help them out. So in conclusion, I just want to emphasize our appreciation for everybody who contributed to the webinar. This was terrific. This discussion is actually very important to our national security. So I'll close things out. Thanks to the attendants for joining us today. Please let me know if you have other topics you want us to address and would like to sponsor. So have a great weekend.
Thank you, everyone. Bye.